We learned how to calculate the empirical formula. How do we get the molecular formula? Because the molecular formula is the real formula. It's the exact formula. It tells us how many atoms of each element are in an actual molecule. And the molecular formula is always going to be an integer multiple of the empirical formula. That integer could be 1 or 2 or 3, it could be 17. It's a whole number. And so that's what this little thing down here, for those of you that like more math things, the molecular formula equals the empirical formula times a whole number. And that whole number would multiply all the subscripts in your empirical formula. Well, how would we figure out what the empirical formula is? Well, here's an example. And this is going back not to the previous example, but the one before that, the gaseous compound containing hydrogen and carbon. And we figured out that the empirical formula was C3H7. Now they're giving us an extra little bit of information here. It says the molar mass of that compound is 86.2 grams per mole. That's the thing we need in order to convert this empirical formula to a molecular formula. Well, it's not because that was the sample, but because that tells us how much a mole of those molecules weighs. Okay? And so what we can do is we'll figure out how much does a mole of the empirical formula weigh, and how many times does that fit into the actual molecular formula. So C3H7, we're going to calculate the empirical formula's molar mass. So 3 times 12.01 plus 7 times 1.008. 3 times 12.01 plus 7 times 1.008 equals 43.086. That's an extra digit, and that's grams. So 1 mole of C3H7 weighs 43.086 grams. But 1 mole of the actual formula is 86.2 grams. Yeah, so he says, double it. Yeah. So sometimes you can see that and sometimes you can't. Well, what if you can't see it? Well, you take the molar mass that they give you and you divide it by the mass of the empirical formula. And you come up with 2.0006. That's really close to a whole number. So that tells us that our integer is 2. And we're going to take C3H7 and multiply it not by n, but by 2. So the actual formula is C6H14. Oh, math, yeah. You can only do this if they give you the molar mass of the actual compound. Otherwise, you can't figure it out. Any questions? We're going to do another one here. So here's back to that adipic acid that we just figured out the empirical formula for.
So it's already given us the empirical formula, right?
Well, we already figured it out, and they're just reminding us of it right now. Okay, so this is what we figured out in the previous example. And they're saying, here's the molar mass. What's the molecular formula for this? So we're going to take that 146 and divide it by the mass of C3H5O2. So we have to calculate that. 3 times carbon and 5 times hydrogen and 2 times oxygen. Five times 1.008 plus 2 times 16. And I came up with 73.09. Anybody else get that? I got 07 too. I just said 09. To trick you. No, I don't know why I said that. Good grief. I really should have my head examined. So we're going to see how many of those fit into the actual. 146 divided by 73.07. And that's going to come out to 2, isn't it? Comes out to 1.998, which is really close to 2. And so then we take our formula here, C3H5O2, and we're going to multiply it by 2, all the subscripts. So C6H10O4.
And 146 is the percentage?
146 is the molar mass.
Molar mass.
And we have to give you that. Okay? So the molar mass is given to you. The empirical formula may either be given to you or they may make you calculate it. And then you find the mass of your empirical formula and divide it into the molar mass of the actual formula. And that's how many empirical formulas you need.